Good morning. Namaste. This is Dr. Uma Kiruvital, Faculty of Agriculture and Veterinary Sciences, Jayoti Vidyapeeth Women's University, Jaipur. I will be taking the course on Metabolism and Bioenergetics Lab, and the first session is to study the principle and operation of a spectrophotometer. So what is a spectrophotometer? A spectrophotometer is an instrument that measures the amount of light absorbed by a sample. And they are mostly used to measure the concentration of solutes in solution by measuring the amount of light that is absorbed by the solution. In a cuvette, the sample solution is placed in a glass container known as cuvette, and this cuvette is placed in the spectrophotometer. This was discovered by scientist Arnold J. Beckman and his colleagues at the National Technological Laboratory in 1940. So, as I said, the process of measuring the amount of light absorbed by a chemical substance, when the intensity of light is being measured, as and when a beam of light is passing through the sample solution, is referred to as spectrophotometry. So over a particular range of wavelength, compounds do absorb or transmit light, and this is the basic principle of spectrophotometry. So what happens is, if we have a sample and we are like passing light through it. So say it has got an absorption spectrum in the absorption spectrum, absorption maxima in the green wavelength range. So green will be in the 500 plus range. So if we are drawing a graph and we are having it like this, that you have the absorption versus wavelength graph, then what will happen is, this is blue, green, and red. So if we have blue here, green here, and red here, then at blue, the absorption will be less. As it goes to green, it will be high, and then it will again reduce and become a very low value by the time it reaches red. So this is what happens for a basic absorption spectrum. So where we are getting the peak, this peak value, that will be the wavelength at which maximum absorption takes place, even though it will be green from this value till this value. Like that's a very basic concept. Like we have 7 colors, but the 7 colors are distributed in the range of like 300 nanometers. The visible light from violet, indigo, blue, green, yellow, orange, and red, the VIBGYOR, is spreading from 400 nanometers to 700 nanometers. So if one light had only one wavelength, then it would have been only 7 wavelengths. That would be like, say, 400 to 407, and visible light would have been over. But there are different shades of each color, and so there are different wavelengths. So if we are saying that visible light falls from this point, green light falls from this point to this point, in which it has got a huge absorption level, but the peak will be at a particular wavelength. And a spectrophotometer basically uses that one wavelength in order to determine the maximum absorption by that compound, and that will be proportional to the concentration of the solute that has been used. So the measurement of this wavelength is very useful in measuring the amount of a known chemical substance, because different chemicals have got absorption maxima at different points. Like if you're using DNA, then DNA has got an absorption maxima at 260 nanometers, that falls in the UV wavelength. And if you are using formazan products, then most of them have an absorption maxima around 450 nanometers because they are yellow colored products. And yellow colored products will have an absorption maxima in the blue wavelength range. Because why? Why is a compound giving out a certain color? Like say, if like this ink of mine, the ink what I have used in this, it is blue in color. Why? Because it absorbs everything other than blue color and it reflects blue color. So the absorption for blue color for this compound that is being used is minimum. And that's why something with a blue color will have an absorption maxima in the opposite spectrum. It will have an absorption maxima somewhere in the yellow, orange, red spectrum. And that way, if you're using a blue colored product, it will have an absorption maxima somewhere in the yellow. If we have a yellow colored product, it will have an absorption maxima in the blue spectrum. And if we have a blue colored product, then it will have a absorption maxima somewhere in the yellow spectrum. So that is the normal principle. Now there is also another one principle that is the principle of scattering. So what happens with scattering? You have a very muddy solution. Okay. Or rather say you have put a lot of glass beads into a solution and then you are trying to pass light through it. Even then there will be only a certain amount of light can pass through it and it will be murky to some extent. Even though glass is actually transparent and it doesn't absorb any light, then why does that happen? That is the principle of scattering. And scattering is also an extremely important principle in terms of determining the number of particulate matter or the concentration of particulate matter in a solution. And that comes in handy when we are studying this bacterial numbers. Then there is a phenomenon called optical density that we are measuring. So optical density is the amount of light which is absorbed by a sample. So in optical density, what we use is we use the highest wavelength light. So around 600 or 660 nanometers light will be used and the amount of light scattered by it will be used. So what happens is if there are particles, they will scatter the light. The more the number of particles, the more it will scatter the light. So the less will be the transmitted amount of light and so more will be the absorption. That is what is the principle of scattering. Now, if for quantitative measurements, spectrophotometry is used because say you have 10 molecules of a blue colored compound. So it absorbs in the yellow spectrum. The 10 molecules will absorb a certain amount of light. Now you have 20 molecules of the 20 molecules or 20 micrograms of the same substance. Like earlier, there was 10 microgram of the substance in 1 ml of solution. And now you have 20 microgram of the same substance in 1 ml of the solution. So the concentration is doubled now. And then what happens? All these 20 microgram will be able to absorb double the quantity of light as compared to the 10 microgram. And when this happens, the amount of absorbance is doubled. So you have 1 unit of the compound and it absorbs a certain amount of light. You have 2 units of the compound and it absorbs double the amount of light. Then what is the limit for this? Say you have 10 units of the compound, but it is spread in such a way that it has become now layers and layers and layers. And so light is absorbed by the first layer, but there isn't enough light left to pass through and be absorbed by the next layer. Then the absorbance will not be equal to 10 times what was observed for the 1 unit of the compound. So mathematically speaking, it should have been. But that is not the case because that is limited to the sensitivity of the instrument, the amount of light it can pass through, the amount of light it can detect, and all that. So if the concentration you want to measure exceeds the sensitivity of the instrument, then you have to dilute the sample and then further use it. So that is the principle of a spectrophotometer. The techniques of spectrophotometry can be used for many materials, many chemical substances. Like in biology, it is very frequently used for enzyme catalyzed reactions in biochemistry. And like the normal glucose detection methods, glucose oxidase peroxidase, that gives a pink color. So its absorption maxima comes in the 450 range. And then you have the Nelson's Homogy method that gives a blue color. So its absorption maxima comes in the yellow range. And these are all methods for the determination of glucose. There are other enzymatic methods, like if for determining superoxide dismutase, you use a WST Formosan method that also gives a yellow colored product. And so its absorption maxima comes in the 450 range. So there are multiple enzymatic techniques that uses spectrophotometry. And then again, for measurement of amount of DNA or for protein, so DNA has got an absorption maxima around 260 nanometers, and for protein you have an absorption maxima of 280 nanometers. And so depending on that, you will be using various techniques depending on what you want to measure and how much of it you want to measure. It can be used for examination of tissues and blood for clinical diagnosis. And then there are other types of spectroscopy, like atomic absorption spectrophotometry, wherein the absorption spectra of a specific atom in a molecule will be used in order to find out the chemical composition of those molecules. So it has got varying methods. Like as I told, it was developed first in 1940. So from then, spectrophotometry has actually improved quite a lot. And so it is now a very advanced method. So now that will be the basic principle of spectrophotometry. So I'll tell you about the basic instrumentation of a spectrophotometer, and we will conclude this lesson. In the next lesson, we will actually go into the details of the instrumentation part of a spectrophotometer. So a spectrophotometer has got two components actually, a spectrometer and a photometer. The spectrometer part is where the light is generated using a lamp. Then it is divided or rather diffracted into different wavelengths using a prism, which is also called as a monochromator. And then there will be a gate used in order to send only the light of the specific wavelength at a specific intensity. So you know what the intensity of the light being passed through is. Then there will be the cuvette placed, and once the cuvette containing the sample will be placed, and once the light passes through the cuvette, this much is a spectrometer. And now it comes to the photometer part. So in the photometer, there will be a photoresistor which will produce a signal according to the amount of light that falls on it. And once the light is giving an electric signal, it will be amplified using an amplifier. And then it will be digitally converted into an absorbance value based on the transmittance received. So I'll get into the details of the absorbance and transmittance and what is the law that governs the operation of a spectrophotometer in the next session. So for this session, please go look into the basic principles of spectrophotometer, and also please look into how a spectrophotometer operates based on how it can measure the chemical and its concentration by the absorption maximum, the amount of light absorbed. So that'll be that for this session. Have a good day. Thank you.